Today we're going to talk about Ross 102b. Is a confirmed Earth-sized planet likely a rocket that is orbiting near the inner edge of the habitable zone of the red dwarf star Ross 102 128 at a distance of 11.007 light years from Earth in the constellation Virgo. The exoplanet was found using a decade's worth of radio velocity data using the European Southern Observatory at the La Silla Observatory in Chile. Ross 102b is the nearest exoplanet around a white red dwarf. It is considered one of the best candidates for habitability. The planet is only 35% more massive than Earth and receives only 38% more starlight. It's likely to be a temperature suitable for liquid water to exist on the surface if it has an atmosphere. The planet does not transit its star, which makes atmospheric characteristics very difficult. Here's a picture of it. It was founded in November 15 of 2017 by XR Fields. Um, yeah, its orbital period is 9.8 days. I mean, it's almost certainly tidally locked. I mean, that means it's an eyeball planet. Uh, Night and day. I mean, its radius is 1.6 Earth. Has a mass bigger than 1.4 Earth masses. Temperatures between 213 and 301 K, depending on atmosphere, whether it has an atmosphere or a very thick atmosphere. Due to it being determined by the relative velocity method, the only known physical premise for Ross 2b is its minimum possible mass. The planet is at least 1.35 Earth masses, or 1.35 times the mass of Earth. This is slightly more massive than the similar and nearby Proxima Centauri b, with a minimum mass of 1.27 Earth mass. Low mass of 1028b implies that it is most likely a rocky Earth-sized planet with a solid surface. However, its radius and therefore its density is not known, as no traces of this planet have been observed. Ross 128b would be zero point 0.5 Earth radius for a pure iron composition and 3.0 radius for a pure hydrogen helium composition, both implausible extremes. For a more plausible Earth-like composition, the planet would need to be around 1.1 Earth radius, but 1.1 times the radius of Earth. With that radius, Ross 108b would be slightly different than Earth due to how a rocky planet would become more compact as it increases in size. It would give the planet a gravitational pull around 10.945 meters per second squared, or about 1.12 times that of Earth. A 2018 study predicts a true mass about 1.8 times that of Earth and a radius about 1.6 times that of Earth with a large margin of error. Ross 128b is calculated to have a temperature similar to that of Earth and potentially conducive to development of life. The Discovery team modeled the planet's potential influential temperature using episodes of 0.367 and 0.75. Photo is the portion of the light that is reflected instead of absorbed by a terrestrial object. With these three potential parameters, Ross 128b would have a temperature of either 294K, 21C, 70F, or 269K minus 4C, 25 Fahrenheit, or 213K minus 60C, 176F. For an Earth-like orbital of 0.3, that would have an equivalent temperature of 280K, or 6C, or 44 Fahrenheit, about 8 Kelvin lower than Earth's average temperature. The accurate temperature of Ross 128b depends on yet unknown atmospheric parameters, if it had an atmosphere. Its host star is a small red dwarf star known as Ross 128. The star is 70% the mass and 20% the radius of our sun. It had a temperature of 3192 K at a velocity of 0.003 and an age of 9.45 billion years. For comparison, the sun had a temperature of 5772 K and an age of 4.5 billion years. Oh, this system is much older. I mean, it's been around for lot longer if it is formed on this planet, making Ross 128 half the temperature and over twice the age. The star is only 11 light years away, making it one of the closest stars. In 2018, astronomers, based on near infrared high resolution spectra, determined the chemical composition of several elements like carbon, oxygen, magnesium, aluminum. I mean, down the list. I mean, presenting Ross 128, finding that the star has near solar velocity orbit. Ross 128b is closely orbiting planet a year, about 9.9 days, and its symmetry axis is 0.0496 AUs. According to some models of the planet's orbit, its orbit is quite circular with an axis of 0.03, but also with a large air rate as well. However, if all orbital models are brought together, then the density is higher, about 0.116, and again, this is subject to a large air range. Get Earth's average distance from the Sun of 149 million kilometers. Ross 128b orbits 20 times closer. At that close distance from the star, the planet is most likely tidally locked, meaning that one side of the planet would have internal sunlight and the other would be in darkness. A 2024 study of the radio velocity data found an estimate of about 0.21 for Ross 121b, higher than previous estimate and similar to that of Mercury. Given the planet's orbit near the inner edge of the habitable zone, such a high velocity would significantly increase its potential habitability. Yeah, kind of shit. I mean, and life's only going to live near the twilight anyway. I mean, let's be honest. Sour flex properties. West 25 8b is not confirmed to be orbiting exactly in the habitable zone. It appears to reside within the inner edge and receives approximately 38% more sunlight than Earth. The habitable zone is defined as the region around a star where temperatures are just right for a planet with a thick enough atmosphere to support liquid water, a key ingredient in the development of life as we know it. With its moderately high solar flex, Ross 120b is likely more prone to water loss, mainly on the side directly facing the star. However, an Earth-like atmosphere receiving one as this would be able to distribute the energy from the star on the planet and allow more areas to potentially hold liquid water. In addition, study author Exo Bennett Fellows noted the possibility of significant cloud cover on the star facing side, which would block out much incoming stellar energy and keep the planet cool. Maybe. I could imagine the sunlight side being very much cloud covered if it's hitting the ocean at least. Um, then this flow would move. The, the rising convective energy would rise in the eyeball and spread outwards across the planet. And that's the way the weather system would, I guess, would work on such a planet. Which is interesting. The planet is considered one of the most Earth-like worlds ever found in relation to its temperature, size, and weather quite host star. Ross 128b is very close mass to Earth, only about 35% more mass than like 10% larger in radius. Gravity on the planet would be slightly higher. Also, its host star, Ross 128b, is an evolved star with a stable stellar activity. Many red dwarfs like Proxima Centauri and Trappist 1 are prone to releasing potentially deadly flares caused by powerful magnetic fields. Billions of years exposure to these spheres can restrict a planet of its atmosphere. Render its stereo with properties amounts of radiation. While 128b is known to produce such spheres, they are currently but the less common and less powerful than those of the previous mentioned stars. Atmospheric potential. As of 2017, it is not yet possible to determine if LAS 128b has an atmosphere because it has not transited star. However, the James Webb Telescope, upcoming massive ground-based telescope, like the 30-meter and extremely large telescope, could analyze the possible atmosphere of 128b as a need of transit. This would enable scientists to find molecules in the atmosphere, besides atmosphere, which are chemical like oxygen, ozone, and methane that are created by known biological processes. And here's some pictures of this planet. Or is it compared to Earth? Interesting. Very interesting planet. Well, that's what we have on it.